In this video, I'm going to show you how to calculate the formal charge of an atom. So the equation for the formal charge is formal charge equals the number of valence electrons minus the number of assigned electrons. Now you can get the valence electrons just from looking at the periodic table. The assigned electrons is more what I'm going to go through today to figure out how do we assign those electrons to an atom. So let's start with the molecule HCN. So this would be cyanic acid. Oh, I'll put in all the lone pairs we have in this. Okay. So first off, we've got three different atoms in here. We've got our hydrogen, carbon, and nitrogen. I'm going to start off by listing the number of valence electrons each of them has. So hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. Now when assigning electrons, there's two ways to think of it. One is that all the lone pairs that an atom has, those lone pairs or those electrons are assigned to it. And then bonds, you count as 1 electron each. What we're doing is, when we're counting a bond as 1 electron for each of them, that means we're considering all bonds as purely covalent. Meaning it's shared completely between the two atoms. So by considering it purely covalent, one atom from the covalent bond goes to one atom, or one electron goes to one atom. The other electron from that bond goes to the other atom. So for nitrogen, we've got a triple bond between the carbon and the nitrogen. And that means we have 3 bonds, right? We have 3 bonds between the carbon and the nitrogen. So the nitrogen gets 3 electrons total from those 3 bonds, 1 from each of the bonds. Then it has 1 lone pair of electrons that count as 2 electrons to give a total of 5 assigned electrons. And that gives you 0 for formal charge. For the carbon, it has 4 bonds, and it gets 1 electron from each of the 4 bonds to give 4 minus 4 and get 0 here. Then hydrogen has 1 bond, so it gets 1 electron from that bond and a formal charge of 0. So in this example, all of them have a formal charge of 0. And notice that the overall charge of this molecule is 0. So the formal charges of individual atoms summed up is equal to the total charge of compound. So this is helpful when you may have a compound that has a negative charge. So when you sum up the formal charges to make sure you did it correctly, you should end up with -1. It's just a good way to ensure that you did your formal charges correctly by making sure that the sum of them is equal to the overall charge of the compound. Now another example I'll go with is NO3 minus. So I have to make sure I draw the correct Lewis structure here. So I've got nitrogen in the middle. Then I'm going to have it double bonded to an oxygen, single bond to an oxygen, single bond to an oxygen. Let's make sure I did this correctly. Okay. So we should have 6 times 3 valence electrons. So oxygen, there's 3 of them, each with 6 valence electrons. It gives you 18, plus nitrogen has 5, plus 1, because we have the negative charge there. So that gives you a total of 24 electrons. So I have 2, 4, 6, 8 from those bonds. And that leaves 16 electrons left over. I have a total of 16 electrons that are non-bonding to get 0. So this is the correct Lewis structure. So I've actually already indicated the formal charges we should get by how I've put the pluses and the minuses here. But I'm going to show you how I get those. I'm just so used to seeing these and drawing the Lewis structures that I automatically know when to put these in. But all these are showing is your formal charge. So I'm going to go through the math to show you how I got to those formal charges. I'll label this as oxygen 1, 2, and 3, and then we just have the 1 nitrogen. So nitrogen here has 5 valence electrons, but then there's only 4 bonds to the nitrogen. So we have 4 single bonds, or we have a double bond, 2 single bonds, but you can think of it as 4 single bonds. So I get 5 minus 4 to give me positive 1. Oxygen 1, I have 6 valence electrons minus 2 bonds, so that's 2 electrons, plus 4 non-bonding electrons to give me 6. That adds up to 0. Oxygen 2, I have 6 valence electrons. I have 1 bond, so 1 electron, plus 6 non-bonding electrons to give me 7. So that should be minus 1. And then oxygen 3 is the same. If I add all of those up together, this gives me a total charge of negative 1, which is the overall charge of this entire NO3 ion. So I'm going to go through some quick shortcuts so you know what to expect a formal charge to be just by looking at a Lewis structure. So for carbon, it will have a 0 formal charge when it has 4 bonds. That could be a double bond and 2 single bonds, a triple bond and 1 single bond, 4 single bonds. For nitrogen, 0 formal charge when it has 3 bonds and 1 lone pair. Oxygen has a 0 formal charge when it has 2 bonds and 2 lone pairs. Those are the most common 3 atoms that you'll see in a Lewis structure. So these are a quick shortcut here. If you have 4 bonds for a carbon, 0 formal charge. 3 bonds and a lone pair for nitrogen, 0 formal charge. In oxygen, 2 bonds, 2 lone pairs gives you a 0 formal charge. So if you haven't checked out the video on how to calculate oxidation state, I would recommend checking that out as well, because it uses a similar methodology, but it considers how you assign the electrons differently.